My name is Hamid Ould-Brahim. I am a product manager in Nokia, working in the area of carrier software-defined networking, which we call Carrier SDN, and represented through a product that we developed called Network Services Platform, which is an NSP. And what I'm going actually to show you here today is to show you a new technology that we developed for the NSP that allows us to automatically and intelligently detect congestion and steer traffic automatically according to some policies that we put that avoid congestion and allows congestion resolution beyond what existing tools deployed in the network can offer. So let me pretty much give you a view on what we mean here, trying to use SDN technology to solve congestion. So pretty much our focus will be on automation and control. Automation implies detection of congestion on a link inside the network, ability to identify the top end path within that link, whether it's tunnels, MPLS LSPs, and ability to identify top end flows contributing to that congestion. The control side, now once the congestion has been detected and we know what traffic is causing the congestion, then the NSP, the product that we designed here in Nokia, is to be able to analyze the network and find the right alternate path that avoid congestion for specific top traffic. And this is according to the policy set by the user. So control implies decide what alternate path to use, whether that alternate path is adequate for the bandwidth requirements, and then move selected traffic to that alternate path. So that the problem space we're trying to address with the Carrier SDN and the NSP and the specific product that we're calling it NRCF, or Network Resource Control Flow Controller, as a module of the NSP platform. So pretty much the element of the solutions, I give you just a quick view before we jump into the actual demo. Pretty much, as I mentioned before, we developed an SDN application that has the intelligence to reroute traffic when congestion happens. We need the ability to collect the statistics and do analysis of that data and feed the SDN application. This is done through the telemetry assurance component. What it does, it allows congestion detection, statistic collection, and flow analysis. And once we have the data, we know what alternate path we need to send traffic. We're going to use the protocol, standard-based protocol, to instantiate the flows inside the network. And we do it through some level of open protocols like OpenFlow or BGP flow spec. So the network reference we're going to be using, so pretty much we have an MPLS network. We're showing you in the demo a node that generates traffic inside the network. And we have the NSP NRCF product sitting as an SDN controller for that network. And we have the NSP assurance component that does the statistic and data analysis of traffic flows. So pretty much the network will be an MPLS network. We show here like 4 routers, edge routers, core routers, and other edge routers. So what we're trying to do, we have a primary label switch path going from router 10 to router 12, and we're trying to detect congestion inside the network. So congestion here is a link congestion, let's say between router 11 and router 12. And once congestion is detection, we want to use an alternate path to reroute traffic, to reroute some selected traffic to the alternate path. So that's pretty much the context of this demo. So pretty much detecting congestion, analyzing traffic, selecting traffic, and rerouting automatically this traffic to avoid the congested link. So once traffic reaches with the policy-based NSP that sends the policies to the network, then the congestion has been resolved. So to switch back to the demo mode, now we have, this is part of the NSP platform front end. So we have here the way NRCF product works is we have like the base protocols like the OpenFlow and BGP flow spec, and beside them there are a number of flow-based applications. This one, what I'm going to show you, is one application among several applications we developed. And this one deals with congestion resolution inside an MPLS network. Other applications we're working on is congestion resolution for IPv4 traffic, IPv4 or v6, and as well egress peer engineering, DDoS mitigation. These are all some of the flow-based applications we're developing. So in that front end, I have like in the base infrastructure, I have the protocol, what we call OpenFlow. And here, for example, we're showing that the NRCF is connected to an OpenFlow. We have an OpenFlow controller. Right now, we're using version 1.3.1. It controls our service router SR routers for Nokia SR routers. So we have we instantiated one switch there, one OpenFlow switch that has one table, and we show as well that switch is manufactured actually by Nokia. So below it, I have the flow characteristic. Initially, when the switch comes up, there's only one default flow. That default flow represents, let's say, these are all standard-based elements, like the cookie, the priority of the lookup of the flow entries when traffic entering the network, how you start going through searching the OpenFlow tables, and all the relevant information that make up a flow. In this case, since we have nothing, this is the default flow, so traffic is flowing normally through the network. There is no redirection here. So besides that, we have the application that we discussed before, the traffic optimization for MPLS networks. What we were doing, the ability, as I mentioned before, detecting congestion, is instantiating what we call TCAs, or threshold crossing alarms. These threshold crossing alarms, when let's say I say in a given link of the network, when you hit 80% utilization, raise an event to the SDN NRCF, and NRCF, when it gets that event, it starts analyzing the data, analyzing the traffic, and identify the top traffic that contributed to the congestion, and make some routing decisions where what traffic to select and where to reroute that particular traffic. So that part of the NSP is based, each time congestion is raised, we show a red flag showing, for example, congestion has been raised, and indicating what interface, what link is associated with that congestion, and as well what the congestion thresholds we set here, for example 2 meg, and what's the rate as well, the average rate. Once this is done, we show as well what are the top end flows that are on this particular link. So as you can see here, just what happened here, traffic has been detected, congestion has been detected on the green, and traffic has been rerouted to the alternate LSP. So let's see here what happened in the network actually. When you see traffic switched from the red here, from the green went down, so we removed some traffic and we put it in the red LSP, and the red now becomes having more traffic. So what happened is this. So traffic, as we showed before in that plotter that shows the traffic rates and for the different LSPs, that what happened here is we received a congestion notification that on the interface number 3, and so we switched traffic. We identified the top N flows, and we switched the first top flows 3.5 meg to the alternate LSP. So let me show you as well in the flow deployment. So in the flow deployment, you will have like two flows there automatically created by the system. And you can do it manually, but in our demo, we're showing that there is no user configuration. Everything is done automatically, trying to really highlight the value of a Carrier SDN that simplify how to operate the network with this solution. So here, like we have a new flow has been added by the system, by an RCF, that redirect traffic to the alternate LSP. And in this case, you can see here the destination address is 38.120.148. That's our top N flow that we discovered. We didn't know that that traffic was there, so we discovered that flow, and we decided to reroute it to the alternate path. And this tool allows us as well to redirect to LSPs, to redirect to VPN, to redirect VPN services, to redirect VPLS services, to redirect to next hop. We have a number of choices that we implemented on the router as well on the controller side. Basically, in summary, what we're trying to do is trying to aim towards making the network more simplified from an operational standpoint and complementing existing tools with Carrier SDN tools that allows more intelligent operation of the network beyond what existing protocols developed for IP networks allows us. Thank you.